So we have another question from pedigree analysis, class 12, chapter number 4, principles of inheritance and variation. So the following is a pedigree for albinism. Now, if you know the inheritance pattern of albinism, it would have been very easy. But since it is not given in your NCERT, we need to find out the inheritance pattern first. To find out the inheritance pattern, we need to focus on the individual having albinism. So this daughter has the trait that is albinism. And both her parents are unaffected. Both parents unaffected. Now this can be possible only when the pedigree here is a recessive pedigree. So we need to find out whether this pedigree is an autosomal recessive or whether it is an X-linked recessive. First, let us assume that this pedigree is an X-linked recessive pedigree. So if it is an X-linked recessive pedigree, then the affected daughter should have X small a, both recessive alleles to express the condition of albinism. Now, she should inherit the X small a gene from the father and the other X small a gene from the mother, which makes the father have albinism. But in the pedigree here, the father does not have albinism. So this pedigree cannot be an X-linked pedigree. Now, if we assume this pedigree to be an autosomal recessive pedigree, then let us find out the possibility of having an affected daughter. Since the parents are heterozygous, that is, they are unaffected, but they can pass down both the small a allele and make the daughter have albinism. So we can conclude that the given pedigree is an autosomal recessive pedigree. So we need to find out the genotypes of the other offspring also. So the parents are having the genotypes capital A, small a. Then these two parents will have the gametes produced capital A and small a. This one also have capital A and small a gametes. Now, if we work out the possibilities, then we have the first two capital A and capital A, small a. And the last two capital A, small a and small a. So the possibility of getting the individual 2-1 to be a heterozygous is 2/4. Or you would have think the answer should be 1/2. But in the given pedigree, this individual 2-1 does not have the trait albinism. So we need to take out the possibility of getting small a. So out of the 3 remaining possibilities, the chances of getting the heterozygous condition is 2 out of 3. So the answer should be option number 3, 2/3. Thank you, everyone.